Hello my dear children of class 11 science. Today again I welcome all of you through this mode of teaching. That means we are following, that is called YouTube mode. And in today's class we do one of the very short chapter on the unit number 7, and the unit number 7 means dual nature of radiation and matter. And the chapter that we are going to do is called matter waves. What is it called? Matter wave. So this is a very short chapter. Okay. So but important concept with respect to this chapter unit, that is dual nature of radiation and matter. Now to start this chapter, so let me just tell you a very important fact, especially with the nature of light, the nature of light or radiation. Now the important fact about the nature of light or radiation, which is verified experimentally by considering different theory and different phenomenon, is actually called dual nature of radiation. So let me first start with this concept of dual nature of radiation. Now radiation means light. Radiation means what? Light. And dual means two nature. The word dual nature means two nature, two different natures. That means light has two different nature. Okay, light has two different nature. So for this to understand, let me just go back to the wave optics. Children, we completed wave optics, one of the sub-part of this optics. Okay. Now in wave optics, the phenomenon, like, so just let's write it down like this point, wave optics. In case of wave optics, you know one of the phenomenon that is called interference. Yes, you learn in details about interference. Okay. Similarly, you learn another phenomenon called diffraction. Even you learn in details diffraction. Even there is one more phenomenon that you didn't learn, but it was not in the as per reduced syllabus. But let me just add, that is polarization. These are the phenomenon which were explained successfully by Christian Huygens using Huygens theory. Okay, Huygens theory means Huygens principle. But this phenomenon, this different phenomenon, okay, actually makes you that the light can travel in the form of wave. That means light has what nature? Wave nature. That means on the basis of wave optics, even other than reflection and refraction of light, that you know commonly, these are also the property of light. Okay, but other than reflection and refraction of light, phenomena like interference, diffraction and polarization were successfully explained on the basis of wave nature of radiation, showing that light from a source can travel in the form of wave. But children, even you know that light wave are the what wave? Electromagnetic wave. Light wave are the what wave? Electromagnetic wave. But this says that light from any source can travel even in the form of wave. And this explain that, and it has verified that light has what nature also? Wave nature. But the concept of wave nature was put forwarded by one of the scientists, as you know, Christian Huygens. And he formulated a principle called Huygens principle. Okay. But on the other hand, there are certain phenomena, okay, and one of the phenomenon that was even explained the nature of light, another nature of light, okay, or radiation, that is called particle nature of light or radiation, is called photoelectric effect. So the chapter that we completed is called photoelectric effect, and this is one of the most common chapter, okay, that actually give you the exact nature or the nature of light, saying that light can travel in the form of light consists of small packets or bundle of packets of particles which are called photons. So this phenomenon shows that light even has what nature? A particle nature. So the chapter that we completed, that is called photoelectric effect, actually explain and I give the idea about particle nature of radiation. Means another nature of radiation. That means light has particle nature also. Okay, but children, at one point, that is called another effect is there, that is called Compton effect, which is actually not in the syllabus, we will not study, but this is another effect that explain what? Particle nature of radiation. So photoelectric effect and Compton effect both explain particle nature of radiation. By considering that radiation as a particle nature, it means that the radiation has what nature now? Dual nature. See, these three phenomena and the wave optics explain what light has wave nature. This says that light has what nature? Wave nature. And this is the phenomenon. These two are the phenomenon which explain light has what nature? Particle nature. And both the nature that has considered, because light So particle nature, even it was successfully explained by these two phenomena. And light has wave nature also, and that was also successfully explained by these two phenomena. Okay, that's why it is considered that the light has what nature? Dual nature. Dual nature means two nature. One is called wave nature as well as particle nature. But so far, children, let me just add one point, that is, there is no single experiment that has been performed which shows dual nature of radiation and radiation. Dual nature of radiation means wave and particle nature of radiation simultaneously. Means light, there is no phenomenon or phenomenon, as I said, which has performed and has been done by any of the scientists which show that light has both the nature simultaneously. These are separated. These are this phenomenon which has explained separately. So children, so we need to accept that the radiation or light has how many nature? Two nature. One is called wave nature as well as particle nature. Okay. Now we go to the next topic where we are actually focusing in this particular chapter, that is called wave nature of particles. Now we go to the next topic, that is called wave nature of particles. So to understand what is actually wave nature of particles, okay, so for that let me just tell you that these are the two phenomena that explain dual nature of radiation, wave nature as well as particle nature of radiation. And as I said already, 1900 is the year, it was the revolutionary year in the field of physics, in which the new idea of nature of light was introduced by the Max Planck, as I said, that is called particle nature of radiation. But there was a scientist whose name was Louis, okay, let me just add the name, Louis, okay, Victor de Broglie, Louis Victor de Broglie, in the year 1924. So this was the year, okay. This particular scientist introduced a bold hypothesis. Now you know hypothesis means maybe that may be true or may not be what? True. Okay. He introduced a bold hypothesis that saying that if radiation has dual nature, see, we already verified that radiation has how many nature? Dual nature. Means if radiation has dual nature, means wave as well as particle nature, then the moving particle of matter. The moving particle of matter. Now let me just tell you children, the entire universe is made up of matter. And the universe is also comprises of radiation. So universe is comprises of matter and radiation. If radiation has dual nature, as per his hypothesis, he said that the particles or matter also has dual nature, or particle also has what? Dual nature. Okay. Now for this he made a hypothesis by saying that if radiation has dual nature, then the moving particle of matter. The moving particle of matter means, like, let me just take the example, like electron, proton, okay, etc. These are the moving particle of matter, should also exhibit wave-like character. Wave-like what? Character, but under certain conditions. So by considering this idea as a hypothesis, okay, he means Louis Victor de Broglie, okay, made a conclusion on the observation that the entire universe, as I said, is composed of matter and radiation. See, the entire universe is made up of matter and radiation. And children, this matter and radiation are always symmetrical to each other. That means every matter has produced radiation also. That's why in this concept, Albert Einstein also formulated one of the famous equations, that is what? E equals to mc square. E equals to mc square. And children, you learn in detail about this E equals to mc square in the next unit. A very famous equation that energy possessed by any mass is given by E equals to mc square. And this relation actually shows that matter and radiation are symmetrical to each other, which means if a matter has mass, that has energy also, in whatever form, whether that mass is at rest, or whether that mass is in motion or anything. So according to de Broglie, okay, he made a hypothesis, and as I said that the entire universe is made up of matter and radiation. They are symmetrical to each other. Thus, with this consideration, these two physical quantities, means one is radiation, one is called what? Matter. Okay, these two physical quantities must be symmetrical in character. So they must be symmetrical in what? Character. Which means matter and radiation must have symmetrical in what? Character. So with this, de Broglie made a statement saying that all material particles which comprises of universe which are in motion even have wave nature also. So try to understand. All material particles that comprises of matter, okay, in motion have wave nature also. So this statement simply makes us understand that the particle of the matter, when they are in a state of motion at appropriate condition, they also show some type of wave nature. They also show some type of what nature? Wave nature. But not at all the condition, only under certain appropriate condition. So from here he made a statement saying that the waves associate with the moving particle of matter. Moving particle of matter means either electron, proton, it can be neutron and other particles also are called matter wave. They call as what? He called as what? Matter wave. So the concept of matter wave was introduced by de Broglie, okay, by making a hypothesis, and this hypothesis also called de Broglie hypothesis. Okay, so as for the hypothesis, the matter's particle in motion also show wave nature, okay, a wave-like character, and that wave associated with the matter's particle in motion are called matter wave, as I said, or de Broglie waves. We call also called de Broglie waves. So matter consists of particles. They already have particle nature, but when they are in motion under certain or appropriate condition, they also show what nature? Wave nature. So as for this particular scientist, he said that not only the radiation has dual nature, the matter also have what nature? Dual nature. That's why the chapter that we are dealing is called matter wave, and the unit that we are dealing is dual nature of not only radiation but also of matter. Okay. Now this hypothesis, initially it was a hypothesis only, but after certain years there are a number of scientists who performed the experiment to actually observe whether this hypothesis is correct or not. So it was experimentally verified. There are a number of scientists who performed experiment, and at last they verified that yes, the matter particle, when they are in motion under appropriate condition, so also a what? Wave nature. That's why this hypothesis was also considered as one of the important part, where the matter also has what nature? Wave nature. So this is the introductory part of this chapter. Okay. Now in the next YouTube video, we actually measure the wavelength associated with the matter wave, and we call this wavelength as de Broglie wavelength of matter wave. And children, that you learn in the next YouTube video.